Welcome to Algebra 1. This video is for the day that I'm absent. Let's start solving for B. You can pause the video and just give it a shot. And I will do that as we monitor each question and stuff. You can always pause the video and try it yourself, and then I'll give you the answer. You can play the video and just watch it. I'll walk you through it. Okay. So given this, you're solving for B. Get B by itself. Isolate B, so simplify, right? So first things first, combine the like terms. You get negative 14 plus 7, which is negative 7. 6b minus 2b is 4b, which is less than 1 plus 5b. I would subtract 4b here. Subtract 1. You get negative 8 is less than b. That's it. You're done. Hopefully that's right. If it's wrong, I would have no idea how to correct it then. Okay, given this, you have a 2 here, you have a 2 here, okay? Correct it for you. To find the x-intercept, you plug in 0 for y, plug in 0 for x to find the y-intercept. So all you do is that. So you're given the equation x minus y equals 2, plug in 0 for y, you get x equals 2. Plug in 0 for x, you get negative y equals 2, so y equals negative 2. So y equals negative 2 is here, x equals 2 is here. Create a line that goes through the x and y intercept, decide whether the line is solid or dashed. Looking at this, I can tell it's dashed, not solid. Okay, you create a line and it's a straight line, okay? Just forgive my straight line, okay? Now, deciding whether which side to shade. Here's the thing: is you either shading the top or the bottom. Okay, pick a point. You could pick 0, 0 or 2, negative 2. I'm gonna pick both of them and just tell you which one makes more sense. Let's plug in 0, 0 first. 0, 0. If that is greater than 2, then I'm doing the top one. Okay, so if you plug in 0, 0. Is 0 greater than 2? It's not. Now plug in 2, negative 2. 2, negative 2, you get 2 plus 2. Is 4 greater than 2? It is. And it's so that this makes sense. I plugged in 2, negative 2, which is on the bottom side. So I'll shade the bottom. Now, I'll say this one thing. You could have just looked at it. You could have just said x minus y is less than 2, is greater than 2. Because y is negative, you multiply the entire, see, x minus y is greater than 2. See, the one way to figure out which side to shade, pick a point from either side, plug it in and see which side gives the correct equation, okay? Second way to do that is getting a positive y here. If this positive y, see, if I need a positive y here, I'm going to multiply everything here by negative 1. And if I do that by negative 1, I won't have to change my sign. Right? Now, y is less than that, right? So I'm doing the bottom because it's less than, because y is positive here. On the quiz, people did greater than, and maybe it's because they didn't see it's negative here. See, if it's negative, you make sure y is positive before you decide whether you want to shade the top or the bottom. Okay? Going to the next one now. Pause the video, see if you can figure out what makes something not a function, right? And I'll give you the answer right now. Look, a function, as long as one input has one output, it's a function. Okay? Different points can have same outputs, but for example here 3 and 4 have the same output and it's still a function. Okay, here 7 and 7 have 2 different outputs. 7 has 2 different outputs, meaning it is not a function. So what would that look like when I graph it? Okay, I'm just going to graphing a random thing. Okay, look, is this a function? This is a function because there's a thing called vertical line test. A vertical line test basically just says this, okay? If I draw a vertical line and it touches my graph only once, it's a function. If I, let's say this is another one, okay? Does this pass my vertical line test? Does it touch only once? No, it touches at two different places. So this is not a function. And when I graph this, see, let's say 7 is here, right? Let's say 7 is here and it's looking something like this. 7, 6 and 7, right? 6, 7. But this is not a function because same output, two different outputs, okay? Definition of a function. An equation is a function as long as there is only one output for each input. One output for each input. If you get two outputs for one input, it's not a function. So let's do another one, okay? Let's look at this, okay? I'm going to random x values. Let's say this one is a function, this one is not a function. An example of that, okay? So here, as long as all of my numbers are unique, they don't repeat, it's a function. Here, I have two ones. So what if I say 0 and 1? This is no longer a function because two inputs, same input, two different outputs. Okay? So, you're given the relations here. They're asking me to plug in input. Input is the x values here. -2, -1, 0, 1 and 2. So you plug in x values for that and solve for y. So when I plug in -2, I get, plug it in, see what you get. I'm going to do it on a calculator because I have forgotten math apparently over the break. I'll get -4, add 4, I get 8. Oh my god, I knew it, it's 8. I'm just going to solve this one for you. You get 2x plus y equals 4, plug in -2, you get -4 plus y equals 4, add 4 on both the sides, y equals 8. Now plug in -1, you get -2, add 2 to the both sides and you get 6. Plug in 0 and you get 4. Plug in 1 and you get 2. Plug in 2, 4 and you get 0. And you can graph it, okay? I'm not going to graph it, you can graph it, okay? I might graph this one, okay? I'll graph this one. But here, your output values is your y. Input is the x, okay? Output is the y, you get -2, -1, 0, 1 and 2. They want you to plug those points specifically in for y. When you do that, you get y squared, -2 squared, which is 4, -1 squared, which is 1, 0 squared, which is 0, 1 squared, which is 1, 2 squared, which is 4. Here you can see same inputs, two different outputs. Same inputs, two different. So this is not a function. And I'm going to graph this one together with you. Let's just do that. 0. So 1 and then 4. Let's just say that, okay? So when x equals 0, y is 0. When x equals 1, y is -1 and +1. When x equals 4, y is +2 and -2 as well. So this, and it fails my vertical line test. This is not a function. Okay, so I'll do one example with you all, just to tell you, just to show you what it looks like. So here 1a maps to one output, but 5 maps to two different outputs, so this is not a function. Here you're given this graph, see if it passes the vertical line test. It fails the vertical line test, so not a function. Here -3 repeats twice, two different outputs, not a function. This, see if it passes the vertical line test. Is there any point where the graph will fail the vertical line test? Nope, this is a function. Okay, I'll do 2 and 3 together as well. See, look at the outputs itself. Look at the inputs 1, 2, 3, 4 and 5. Are there any repeated? No. So this is a function because no input is repeated. Here, does it pass my vertical line test? It does pass my vertical line test, so yes, it's a function. Right? See, this one would fail. Now, it's practice time. You got this. You can turn in your exit ticket, and that will be all. Again, write it down in your notebook as well, okay? If it passes the vertical line test, it's a function. If it if there's only one output for each input, it's a function. Okay, all right, we got this.